of things. Sounds like there was an audit, maybe something around pre-confs and the policy there, and then yeah, maybe integration with rated. So yeah, to kick us off, anyone want to speak to the audit? I don't know, Drew, if you have an update there.
It's going to be Lorenzo.
Okay.
Yeah. Hey everyone. So yeah, last week I guess we wrapped up the audit. The audit covered mainly the, let's say, central PBS logic, so the PBS module, and not yet the signer module. And this is also because the signer module is still undergoing some changes. So we thought just to get the PBS to start. Overall, there were no, let's say, critical or high issues in terms of risks. There were a few, let's say, medium, and then a bunch of like low or informational. Most of the stuff was just around header validation and adding some retries to registration and submitting blocks. So say nothing too risky. Yeah, and then so yeah, that was overall a few weeks. We had very good communication with the Sigma Prime team. Then we received the first report. Then we fixed all the issues, and you can see those in the latest release, which is 4.0.4. Yeah, that's it. That's the audit, and yeah, no more vulnerabilities, hopefully. And I think when we are at the stage where the signer module is also more stable and we're comfortable, then we're going to go ahead and get that audited as well. Yeah.
Cool. Do you have a sense of the time on the signing module?
I would say definitely, let's say by the end of January, I would say we're gonna reach a point where it's gonna be stable. And right now is mainly integrating new signers, and but the flow is mainly there already. Yeah.
Okay. Yeah. That one's just very important. So the sooner we can get an audit, the better.
Yeah.
Cool. Okay. Well, yeah, it's exciting to hear that there weren't any crazy issues. And yeah, I guess so then you'd say like 040 of the PBS module has been audited.
Yeah, correct. So the PBS module has the latest version has all the audited part, and then on top of that, it also has a couple of things that we added after the audit started, which I guess I was going to talk about in the technical days. Essentially, it's just a multiplexer and support for custom genesis and for kurtosis, basically. So, but then all the rest is audited.
Cool. Yeah, that's big. Yeah, okay. I can look at that later. It looks like the audit's linked from, I think it's both here in the agenda, but also on the repo. So yeah, that's a nice, very nice thing to see. Cool. Okay, if that's it for the audit then. Next up, discussion around pre-conf base commitment policy. There's a post here. Looks like this one's on the Lido forum. Drew, I think you wanted to bring this up.
Yeah. So I wrote this post a little whiles back at Bangkok, and then subsequently there were some tweets about a potential policy across Lido. Just wanted to flag for the group that any policy that gets rolled out impacts not only Commit Boost, but everyone pretty much that joins these calls, whether you're a validator, module creator, or community member, or Ethereum staker, anything like that. And so would encourage people to read this. This post wasn't a shield of Commit Boost, just some principles to think about. If Lido were to create a policy, what they should keep in mind. And yeah, from my perspective, just emphasizing transparency, controlling from conflicts, and particularly where we're at in the market today, where there are no pre-comps, there likely won't be till Q1 of next year, other than the couple teams we have running, but limited traction so far. And just like being very cautious around limiting or being exclusive to any one provider to make sure the market can flourish and there's full competition. So that was the big parts, then trying to make it as future proof as possible, which is really challenging. And there's a balance between safety and that. But there's going to be other proposer commitments in my mind. There already are that are popping up. And in particular, early next year, we'll start to see the form beyond just pre-comps and inclusion lists, which we've talked about. And so if people have comments, thoughts, would encourage them to go to the post and give it a like or support or push back or comment with your own views to help Lido create the best policy possible.
Cool. Yeah, this looks nice. Is there like where should people engage to follow up on this? Like just on the thread here on the
Yeah, on the
forum?
thread, there isn't anything on Lido yet around what the policy is. So this is kind of like a pre-discussion of the policy. Just know it's being crafted or thought about, and so thought it'd be helpful to at least get my thoughts out there, and others if they want to join.
Yeah, definitely. Cool. Yeah, any questions? I'm not sure if people have had time to look at it. Okay. Then we'll move to the next item on the agenda, which is an update from Rated and evaluating different modules. I think someone from that team is here.
Yeah, were they able to join? I just got a ping.
Maybe not. Do you know kind of what they've been thinking, Drew? Maybe you could just give us an
Yeah,
overview.
we may need to go to the next item and then come back. Illis, I think he's about to join. He was having problems joining.
Okay,
But
no, that works.
why don't we come back to this?
Sure. Cool. Well, then next up, yeah, moving into technical updates. Yeah, anything since the last community call. It's been a little while since we've had the last one. And yeah, I think Lorenzo, I think you mentioned there was something you touched on earlier.
Yeah, so I guess since the last update, or mainly the audit, and then in terms of new stuff, it's a multiplexer, the main thing, which is basically allows you to, with a single sidecar, to direct on a per validator basis to different relays. And this is something that there's also a presentation just after now, where Sebastian was going to go more in detail in how they use it and how it can be useful also to uh, select and create a more, let's say, select different protocols. And I guess you'll see in a second. The other thing is we added the kurtosis support and also testnet support, where you can override the chain spec with a file. And yeah, those are the main updates on the PBS side. And then on the signer module, we've been, I guess, Lambda class has started helping a lot on the development side, especially Manuel, who's I think here.
Yep.
Yep. And then, so the main updates there, I guess, is the support now for Web3 Signer, which landed on main last week. And then we also started improving just the signer model. So there's metrics now around that. And we proxy keys, which basically, I guess everybody's familiar now, but it's just ephemeral keys that are generated from validator keys. They're now stored locally using the ERC2335, I think, key store format. And then short term, we're looking to add on the multiplexer side support for Lido. So right now, the way you specify validator public keys is just by hard coding them or loading them from a file. But we're looking to add support where the node operator could just specify the Lido operator ID, I think it's called, and then this would load from the chain the public keys. And then on the signer side, we're looking to add support for Dirk, which should be done, let's say, soon. And yeah, those are the main near-term updates.
Cool. Uh, I believe we have support for both BLS keys and also, SecP keys, right?
Sorry, Oleski?
No, sorry. Just in terms of like this proxy key architecture that we settled on, I remember last time we were talking about like what do we support, and I think we landed
Right.
on having both support for BLS keys and also the key within Ethereum,
Yeah.
the execution layer.
Yeah, so
Um,
they're both supported now, and some key managers will not support both. So depending on which kind of key managers, then only a subset. But let's say if you're using, for instance, the local key stores, then you can request a proxy that is BLS or a proxy which is ECDSA.
Yeah, okay. The reason I bring it up is just that an update sort of on the core dev side of things. We'll have BLS precompiles in Pectra. Something that would be cool is like if there's like sort of proof of concept or something of the software using that precompile, that'd be super cool. It would also be nice feedback if someone did this and found out that it was like really expensive in terms of signature verifications or things that are needed. So yeah, if anyone here has some interest in that, DM me and maybe we could work on a prototype or something. Um, yeah, just wanted to shout that out. Oh, any other technical updates, or does that pretty much cover it?
Yeah, yeah, that's it.
Okay, nice. Cool. Then we can move on. Well, actually, do we want to circle back to rated? I think, is this Elias here that is with the rated team? Or am I mistaken?
No, you're not mistaken. Let's come back to
Okay.
him.
Okay. Still some connection issues. This is the hardest part of our job. Let's see here. Okay, cool. Then we'll move on then to validator updates. Looks like we might have something from Chorus One and also Kelm. So yeah, Chorus One. Looks like there might be a presentation.
Yeah, hi. My name is
Hello.
Maxim. I work on Ethereum validators in Chorus One. So today I will be presenting our recap of running comment boost on testnet and for a little on mainnet. So let me share my screen and go through presentation, and then we can ask questions basically. One moment. You see my screen now, right?
I do not.
Not yet. Okay. One moment.
Okay, I see it now.
Okay. Yeah. So our reflections on a few weeks evaluating comment boost and Holaski and Helder. So Chorus One, yeah, we are node operator and validators on over ATR networks, operate 10K validator on mainnet and 40K validators on Noises. We provide PBS capacity to all customers by default, and we use MEV boost in production since 2022. So our evaluation goals were like integrate comment boost into Chorus infrastructure, compare MEV boost 1.8 with comment boost PBS. So it was 1.0, it's 0.1, it's older version. Now there are updates and presentation will touch it in a bit. And benchmark latency added by one or another solution where applicable. So what do we run with comment boost? So we run for 100 validators in Helder, 250 validators in Holaski, and also we run like 500 other validators in Holaski with MEV boost from Flashbots. So challenges on Helder. So despite proposals very open, Helder relays were unstable, sometimes downtimes for days. Helder setup uses a single relay right now, which is not realistic as compared to typical main PBS setup with multiple relays connected. So we evaluated multiple experimental steps with Helder, inclusion lists, chain-bound bolt, which makes it not fair for the comparison with like MEV boost and between MEV boost and comment boost. So we decided to not to use Helder data for benchmarking. So on Holaski, there is different set of challenges. So actual proposal does not happen very often because everyone knows there is a lot of validators on Holaski. So we didn't have a good statistical sample for the proposal itself. The latency has large variance across relays. We will see it like we used not one relay, 3 relays, so it's kind of much closer to what people usually run on mainnet, but they are different. So while errors are not that often as in Helder, about 2% of all requests were errors with both MEV boost and commit boost. So it was like very similar, which is still significant as compared to mainnet. On mainnet, like usually there is much less errors. So with this in mind, we can only benchmark validator registration and relay status check. So this happens on Flask like every epoch or every slot. So there is a lot of statistical data. Yeah, so this was our setup. Commit boost 250 validators, MEV boost 500. We both used Lighthouse, just with different execution clients, which are probably not related to this benchmarking, and the same set of relays, Flashbot, Cystos, and Titan. Yeah, and we run it with like for 17 days. So this is relay health checking latency. You may see so this like lighter is commit boost results, and darker, and this blue one is actually MEV boost results. So yeah, well, like mean, median 50, 75 is 95. You can see that normally like commit boost is much faster on the status checking. I know there is now a setting to skip the status checking, but we still use with it. And generally, we are going to continue use relay checking for now. It doesn't give any like significant timeouts with commit boost, as you see, like no additional latency. Yeah, so inside the variance of relay of latency between different relays is very significant for status check. Commit boost is generally faster, but for slow relays, it nearly matches MEV boost. For very fast relays, status checking is up to 10x better on commit boost. So this is validator registration latency. So here is legend is different. So the slide colors is commit boost, but MEV boost is combined. So I'll explain why it happens. So essentially, when this benchmarking was done, there is also a new setting was added by commit boost to facilitate it. But like by default, the check-in works like that in commit boost. So the register, sorry. So the register request goes in parallel to all relays, and then commit boost waits on a response from all of them, and only after that it answers to basically client. Where MEV boost, yeah, for MEV boost, they answer as a get answer for the first relay from the first relay. So they don't want for other relays answers before answering to a client, to a beacon node, in our case, Lighthouse. So you may see, surprisingly, MEV boost went much faster here, but this is mostly just because we weren't waiting for answer for all relays. Yeah, so yeah, so inside MEV boost does not report registration separately, and also it doesn't report registration errors if at least one of relays was successfully registered. Despite this, commit boost was significantly slower. Found this difference to happen because MEV boost sends registration to all relays. Yeah, I've already explained that. So it's possible to skip waiting now with this wait till registration false setting in PBS module. So the relay checking logic will be skipped, and there will be no relay compared with MEV boost. No delay. Yeah. So what else? So we are using commit boost for integration with chain boundary confirmation testnet, which going live very soon. So we tested commit boost on mainnet with limited amount of validators, basically on stake, and successfully proposed 2 blocks. There was not much validators, but yeah, it was all worked very well. And we scheduled to start replacing the MEV boost nodes with commit boost one by one in the second half of December. So thank you for attention. If you have any questions, feel free to answer.
Cool, thanks. If you will go back to the slide about even just like relay checking, do you have a sense of like the even like ping latency to each of the relays?
One moment.
Like it could be the case that the Flashbots one is just like further away.
Let me then reshare.
Okay.
So you're asking about relay or registration? Relay
This, yeah, for example here, like it could be the case because we see that like the Flashbots relay is much slower than all the others. but
Yeah.
it could be the case that it's just further away on the internet. So I was wondering if you looked at like ping latency at all.
Yeah, it may happen. So I think the performance boost here is just because of using two different HTTP client stacks, and commit boost is a faster one. But indeed, for relays which are like located on the internet, like more in more distance, so the transfer will take most time of basically answering. So here you see like IS2 is performing very fast on the MIB boost, so probably it was very close to our node, but yeah, we haven't checked it. Actually, would be interesting data to find. We'll share if we get an answer. Yeah. Any more questions?
Yeah, and I guess just on the other graph with the registrations, it just sounds like commit boost and med boost use different sort of strategies around handling responses. So it's kind of hard to compare them.
Yeah, so I've have additional common side from here. So actually, MV boosted just gets headers from response, while
Your connection's kind of cutting out.
gets to be still slower, and so
Okay. Looks like he
Maybe
fell off.
I'll just say a couple of things on that. Yeah, so the main difference was how we were waiting for relays to respond in commit boost. So in MEV boost, it was waiting for the first one to reply. While when this benchmark was done, we were waiting for all relays. So basically, we're bound by the slowest relay. So that's why the benchmark seems a bit off. But then after we discussed this with course one, and now there's a flag that can be turned on or off to change this behavior. So probably like when this flag is such that the behavior is similar to MEV boost, I would expect the time to be very much in line with the two.
Yeah, makes sense. Cool. Anything else? Otherwise, we can move on to an update from Kelm.
Yeah, I can take it. Let me share my screen. Can you see my screen?
Yep.
Yeah, so the idea was to present a bit of features that was added to Commit Boost, which is multiplexing, sorry, and explain a bit what it tries to solve. And also, if we have some time at the end, I would like to touch a few points on some guidelines for module writers and designers. So yeah, just some context on what it looks like to operate validation keys on Ethereum with Commit Boost. So if you are a solo staker, your setup probably looks like this. So you have validator clients at the bottom, which have validation keys. Validator clients have to be connected to beacon and execution pair. So this is usually the heavy stuff that happens here. And on the beacon side, you will likely set up a builder URL to point to an instance of Commit Boost, which then will be connected to multiple relayers. And so whenever you propose a block, it goes through the, well, beacon asks the relayer, asks Commit Boost for a header, which gets it from relayers. The header comes back to Commit Boost, which gives it back to beacons so that it's signed by the client, and there is this sort of dance that happens here. So this setup is quite simple. Well, for some definition of simple, it has like two downsides. One is like low reliability, which is usually not a problem for solo stakers because Ethereum is like quite okay with attestation misses and this kind of stuff. And another issue is that with this setup, all keys are going through the same set of relayers. So if you have two population of keys and you want to configure them differently, which could happen, for instance, as a solo staker, if you sign up for the Lido CSM module, for instance, where, as you know, like Lido has a vetted list of relayers. So you explicitly need all your Lido keys to point to a specific set of relayers, and maybe you want a different configuration for your own keys. And if that's the case, the setup becomes like this. Like it's kind of like cumbersome, but like there is no way to do otherwise without multiplexing. So you have to duplicate your stack, have one stack with one validator client with a set of keys you want to use on relayer 1 and 2, with like a dedicated beacon, dedicated execution node, and dedicated commit boost instance, and do the same on the other side with a second set of keys. So like this setup is quite complex and costly. So like this is for solo stakers, and for like more advanced operators, you likely have like higher availability because you don't want to have downtime as it's your job to run keys. And so one typical setup is to like connect the validator client to 2 beacons and have one as a primary and a second one as a fallback. And so whenever like this beacon pair is going to like beacon exec pair goes down for some reason, or like, I don't know, you have to upgrade it or something, the validator client is going to automatically fall back to the second beacon and go to like proposed blocks via the secondary pair. And so like this sort of setup gives higher availability. The cost is 2x, but you still have the same problem as that goes through the same relayers for like all validator keys. And so this setup becomes like this. It's becoming a mess if you want to operate different set of keys with different sets of relayers. Here you have like the 2 population of keys that are split in 2 parts. On the left side, you have like one validator client with like 3 keys going to like this pair, and on on the other side, the other set here. And then you configure like each commit boost instances to point to different relayers depending on what you want to do. And as you can see, like this kind of setups is quite complex, costly, and like error prone. And this is what multiplexing addresses. So the idea of multiplexing. So yeah, this is something we have been using at Kin for years now. Like we have our own implementation of PBS, and it was implemented in Commit Boost by Lorenzo. Like we gave him some guidelines on how it could be done, and like this is what it looks like currently on the configuration side. So the idea is quite simple. Is like on the Commit Boost configuration side, you define sets of keys and then the PBS configuration that goes with it. So if you want like your Lido CSM keys to go through a specific set of relayers and your own stakes to go through another set, you can do it that way. Like you define all the relays first, and then you have like a first group of key that you can identify by a list explicitly here, and you define the relays that it should go to, and similarly for the second set. And so this kind of setup here, like for the solo staker, becomes this. So as you can see, like it's quite the same setup as we had initially. And so validator keys can be like mixed on different validator clients, and then it's the job of Commit Boost to use the specific set of relayers that you want to use for each set of keys. If you have any questions on this, like feel free to ask. And so like this big setup here for larger node operators is simplified into this. So that solves one issue which folks can have, like, is like be able to specify different set of relayers for different set of keys. And now when we talk about pre-confirmations, and like most of them like are trying to be PBS compatible, which means you can actually do these sorts of configurations, as in consider that like a local sidecar, like with like a specific pre-confirmation system, can be treated as a relayer inside the multiplexing configuration. And so that way, you can also, like via Commit Boost, have different strategies, different pre-confirmation strategies without having to duplicate your infrastructure. So in this example here, we have 3 relayers. One is ultra-money, so it's like a classic PBS relayer. And the other 2, you can see like the link points to something in on the machine itself. So this could be like a bold sidecar or like other modules that are being like currently developed on the commit boost side. And so then the idea is like on your configuration, you can say, okay, I want this set of keys to go through PrimeHub, I want this set of keys to go through Bolt, this other set through ifgas, and so on. And so within commit boost, it would look like this. So multiplexing is like a functionality offered by the PBS commit boost module. So at the entry point of everything, there would be like the commit boost PBS module. So on all of your beacons on your infrastructure, you make it point to the commit boost PBS module. Inside the commit boost PBS configuration, you define your multiplexing, and then it points to different internal modules that are either running as a sidecar of commit boost or like directly communicating to the outside with classic PBS configurations if the pre-confirmation system does not rely on a sidecar. And that way, like we can have these sort of setups where there is no extra cost or like complexity on like the pure infrastructure Ethereum side, I would say. And then all of the configuration of like which preconf you want to use, which layer you want to use, and so on is undone in a single place, which is the configuration of commit boost. So yeah, that's basically what multiplexing is doing. Yeah, I don't know if you have questions on this. Then I have like, yeah.
Rather not a question, but ask about the functionality. So is there will be support for default rules, right? So when you got proposal from a key which is not matched with any rules, will it be possible?
Yes. Yeah. So there are the current way. So this is something I think we were modifying with Lorenzo yesterday. But like, if you don't specify, so yeah, the keys the set of keys you configure here, they are exclusive, as in you cannot have a key that is present in multiple places. Each key set is independent, and for everything that does not match one of those key sets, is going to like use the default relayer list. So that's the idea. Thanks. So like you can and also like one feature that's going to be added, like so you see here in the configuration we specify the set of keys explicitly, and as Lorenzo was mentioning, there will be a way to like specify just say your Lido operator ID, and then automatically commit boost is going to fetch through the smart contract of Lido all of the keys that you are managing as an operator, so that you don't have like to explicitly go fetch your Lido keys and so on. And we could imagine other like sort of filters here, like SSV support or like things where validation keys can be looked up on smart contracts or yeah. So the idea is to have like a simple central configuration for operators. So yeah, then I don't know if we still have time, but like for this to work well, it works very well if the pre-confirmation module is stateless. And by stateless, what I mean is like, as you know, on PBS, when like there are 3 calls, basically, like whenever the validator client starts, it's going to call an endpoint to register validators on the relay. Then it's going to call getHeader whenever it has to propose a block, and finally blinded blocks to like propose a block. And so a stateless pre-confirmer, like a stateless module here, would be a module that where there is no dependency between the 3 calls, as in like the code that handles the getHeader call does not assume that there was a prior call to validators, and same for blended blocks. So I will show an example where like what I just presented can be problematic a bit after, but basically if you are like using a pre-confirmation system that goes through classic relayers, there is nothing to worry about, and all of this is going to work well at scale. And yeah, I wanted like, so like this discussion here, I think is more like for module designers, but I wanted to point out to like one problematic case that you can have if you have modules that keep a state. let's say like the validator client starts, so it's going to call the registration. Yeah, it's going to call /validators, which is a registration PBS call on the beacon on the primary beacon here. So commit boost one is going to receive the registration call. And so at this stage, the module that is here, that is like the pre-confirmation system, is going to know that the validator is ready to like accept pre-confirmations. And the issue is that if for some reason the validator client here falls back to this beacon, to another beacon, because there is, I don't know, network hiccup, or like the operator is upgrading the beacon, or like there is a crash somewhere or something restarts, there is a possibility that a state will be kept here with some pending pre-confirmations, while the validator client will go through a different path. And so what's going to happen when it falls back is going to like register here. If there is a pre-confirmation module here as well, it's going to like see, oh, okay, this validator is going to propose a block soon, so I can accept pre-confirmations. And you can be in a situation where you have like pre-confirmations that are pending on both sides, and only one side is going to select the block proposal path. So what this concretely means is that some pre-confirmations here will be skipped, and the block will be proposed, and so the validator will probably be slashed if that's like, yeah. I don't think I explained it very well, but like this does not happen if your pre-confirmation system is stateless. And I have a workaround proposal for this here. I don't know if, yeah. Like, do you have questions on this, or I can try to rephrase it maybe?
I think it generally makes sense. We only have until the hour, so I wonder if maybe it's best to do this async to really get into the details here. I don't know.
Yeah, sounds good.
What do you think, Drew? Yeah.
Yeah, I think so. I think there's interest in this. And maybe, yeah, if you can send the link or presentations people are asking. But yeah, we gotta keep going.
Yeah, too
Yeah,
bad. We were just getting to the most interesting part, but yeah, I agree on time.
Yeah. I mean, the Muxing is super cool. It makes a lot of sense. And I agree, yeah, there is this issue with statelessness with the modules. I'm not sure what's the best place to follow up though.
Ping, yeah, ping the community chat, or Sebastian, and I think Lorenzo's at Gattaca has been helping on this too and thinking through it.
Yeah, there is a proposal here that can address it. It's not like 100%. I think there are better solutions. It's just like an attempt to like have this work. But yeah, maybe we can go like take this offline, or like it would be easier. I don't want to monopolize the time here.
Yeah,
anyway,
maybe
like,
make an issue on the commit boost repo and we can go from there.
Sounds good. And
Cool.
yeah, just finally, like just to share a quick status on what like I just presented. Like, so PBS muxing has been implemented by Lorenzo. We have tested and qualified it with multiple relayers and about 50,000 validators on Holesky. We are still like iterating on this. Like there are still like few changes being made to commit boost to like work well with internal modules. So yeah, most of our current state, like our current focus right now is like be able to have multiplexing with with local modules. Yeah, that's all I had to say.
Cool, thank you. Yeah, no, this is super nice. The diagrams are really good too. And yeah, there's a link here in the chat to them. Yeah, and yeah, I guess, yeah, just open an issue around this like stateless in this question, and people can engage there.
Sounds good. Thanks.
Yeah, thank you. Okay, should we circle back to rated?
Just a quick question. This is
Oh, yeah.
Thanks for the presentation. This is all part of the unaudited part of commit boost, right? Just to be clear. Okay, I see Lorenzo nodding. Thank you.
Okay, rated. Do we want to circle back to them?
Cool. Yeah, I can take on it. Sorry, I thought that Drew was gonna MC me in, but I guess Alex did. All right. Hello, everybody. Elias here. Nice to see a bunch of familiar faces in this call, and thanks for having us on. So the context is that we started a conversation with Drew, must have been a month plus back, about risk scoring and performance monitoring on different commit boost modules and gateway operators. And Drew invited us to take a closer look and see if we'd be interested in contributing and high level, important effort extends Ethereum in important ways. So we would be super down principally to contribute. At the same time, we sort of would have to balance out somehow kind of our involvement here with opportunity cost, and in general, we'd have to basically price the size of the opportunity of getting involved in what that could, what we're giving up, and what we stand to gain. So we had a conversation where Maxim from Chorus One and Seb, who are both here, we're involved, and we talked about sort of analytics for validator operators in terms of new modules or old modules. And obviously folks have their own telemetry, but like we've seen with the work that we've done for Ethereum validators, that's part of the story. And then having sort of the whole landscape sketched out allows people to benchmark appropriately, and that drives interesting learnings and improvements thereafter. But there is a key difference in sort of the validator landscape on the Beacon chain and what we're talking about here, which is market structure and how that's likely to pan out. So there is a lot of unknown unknowns, and what I wanted to get out of today was to hear what from other validator operators. So actually, before I even go there, there's two things in question. One, how valuable and what exactly in that sort of sphere of value do validator operators find valuable? The second aspect is the mode at which the relevant data to build upwards into context of risk and performance on an ongoing basis, informed by data. Where does that data originate from, and what is the transmission interface? So one solution to this is the status quo, which is data APIs on relays, extend that to gateways, and you have a solution there. A different solution would be to have validators and possibly gateways actually piping data out and emitting data to a data store that might or might not be commonly accessible, from which more easy to use and enriched and useful context can be built. So I'd love to just hear people's thoughts, maybe starting from point number one, which is, especially if we consider that this is, for the foreseeable future at least, not going to be a world where there's going to be a lot of people competing to offer these services, how important, and not a lot of entities, rather, and then feel free to challenge me on that assumption as well. But how important would that sort of visibility be for operators here, and why? And if possible, I'd love to hear from both sides of the aisle if we have them. So both from gateway operators as well as from validator operators. And I'm not fishing for a directional answer. It could be like, actually, we don't give a flying F. But it could also be that, oh my God, this would be actually very valuable for XYZ reason. So feel free to go unfiltered. We're gonna take your silence as we don't give a which is also valuable.
I can give some comments from like the perspective of a gateway operator. I think the value add there would be that there's an unbiased source that can sort of provide some metrics and transparency in regards to operations of the gateways. So I think even just rather than gateways making that data available themselves, ideally there are some monitoring tools, and there have been discussion points on how these could be put into place. I'm not going to go into any details, but there will be like some actors in the network that will do or be providing observability services, ideally about the performance of issuing pre-confirmations around timeliness and uptimes and a bunch of other things. And so I think it's quite important that there's some entity that is as neutral as possible that can make that data available. Now, I don't have a view on who is willing to pay for this and if that is monetizable. I think I don't have much input there, but I think it's definitely important. And it can't be offered by the gateways themselves because that's obviously going to be biased data.
So pinging someone that pings from the outside in kind of thing.
Yeah.
Or a listener that's
So for example, one design around like monitoring uptimes and responsiveness was that some of the RPCs could just be run in a TE. Everyone can look into like what kind of code they're running, and the TEs will attest to that. And what they will do is basically whenever there's a pre-conf request being made by a user, they can just output the response times and if they confirm stuff and things like that to some sort of DA, and that will be like a credible source of truth around like what gateways are doing. But obviously that data will still need to be handled by someone and need to be made available and digestible easily.
Yeah. If I can chime in, I fully agree with Kubi, and I think we can further split the assessment into two main categories. One is like the risk that node operators incurs per node per module. So assessing like from a simple thing from like is the code open source to like much more intricate stuff, which I want to go into the details, but I want to get to the point of having a sort of qualitative understanding of the module with a few properties that we can all agree are important for node operators to have underhand when evaluating a given module. And then the second section is instead statistics on the day-to-day operations of the module. I think the Mav Boost dashboard about builders and so on is probably one of the strongest shelling point between builders and relays. People can see how they're performing, etc., and also see overall like the flows and so on. And it's a very, very, I say, simple dashboard. So if we could have something like that with, again, properties that are simple from number of transaction to response time and things like that, it's going to be helpful. And yeah, third point is I fully agree if it's someone that's not a module or an operator or one of the two or a gateway would be more neutral and better. Regardless, there are a lot of people here that have incentive of doing it, of doing a dashboard and keeping it well. So it will be done anyway, in my opinion. But I think if we can have it truly neutral and truly done by people like you that built amazing reporting system with a lot of credibility and also good benchmarks, it would be great.
I appreciate the kindness. Anyone else would like to chime in?
There was one more thing to get through on the agenda today, so I would suggest we move on. But yeah, is there a place to engage async?
Folks could come over by our Discord or DM me on Telegram. I'm at Eliasimo, so I'm gonna leave it in the chat, and then we can
Yeah,
pick up the conversation from there.
I can add you in the community chat too. So then
Cool.
people can ping you.
Cool. Okay, thanks. Yeah, last thing then was module updates with Bolt Boost. Does someone from Bolt want to? There we go. Okay, cool.
Yeah, sorry. Can everyone see the presentation?
Yeah, I can.
Lovely. I'm gonna keep it very short. So we just want to give a quick update on the Bolt X commit boost integration status. Hold on. Okay, perfect. So we're currently testing on Holesky with the option to run Bolt like as a commit boost module. And we've actually successfully landed some precons with this setup with external node operators on Holesky. So that's great. And if you're interested in the testing guide, if you want to participate as a node operator, this will direct you to the commit boost setup where you can run Bolt with commit boost. So let's talk about the current setup. Current setup on Holesky is right now we have the Bolt sidecar and Bolt boost, both running inside of commit boost. The Bolt sidecar runs as a commit module, which means that it has, or like in the future, it will make commitments and interface with the signer module. And Bolt boost is just an extended version of the PBS module that implements the constraints API. So the API that's needed to communicate precons and constraints down to all of these relays and builders. So this is the current setup as well on Holesky. Now, yeah, so if you want to look at the code, it's open source. Here are the links. I will also share the slides in the chat after. And let's talk about next steps too, real quick. So Sebastian mentioned that muxing is going to be really important, and that's something that we want to support as well. It's still a bit unclear how it would work with us, but the main setup is the beacon node connects to a muxer module, or which will probably be the same as the PBS module. So that's where the difficulty sort of lies. And then the muxer can sort of decide which validators use the Bolt module and which ones, for example, just use a regular PBS pipeline. So that's something that we want to support and chat about. And then finally, we would also like to use the commit boost signer module when that's generally available. So right now, the Bolt sidecar just gets keys loaded in via environment variables, command line parameters, stuff like that. But ideally, we'd like to have like a vetted signer module that takes care of storing these keys, interfacing with external signers, and sort of exposes a signing API. So this would be ideally in the medium term what the setup would look like. So the muxer would be there as well as the signer module, and everything would be audited and done, hopefully. And so the open questions for us right now are figuring out how we can make the muxer work with the Bolt sidecar, which up until now has sort of assumed exclusive access to the builder API, which is not something that would work in the setup where you have multiple modules. So that's something that we're trying to figure out. But yeah, that was basically it. If anyone has any questions, feel free to shoot. Great.
I don't think I have any
I guess.
questions. Yeah, but it is exciting to see the progress, and yeah, cool that you had it running on the testnet.
Thank you. Yeah, we're still in the process of operating more external node operators, but we'll definitely keep everyone posted in these calls as to how that's going.
Cool. Great. Yeah, if there are no other questions there, we are almost at time. So are there any closing comments?
I would just have a quick question regarding the signing logic. I think Kubi Lorenzo, you mentioned earlier that you're working on integrating like external signers like Dirk and Vouch and Web3 Signer. I'm just wondering, like, what is the status on allowing for like the vanilla and particularly all vanilla beacon client validators to hook into the commit boost like signing logic?
So we should already support most of the vanilla, let's say, local signing methods. So yeah, Prism, Lodestar, Lighthouse. I feel like there's another one, but
Teku.
yeah, most
Teku also.
Manuel.
that one. Yeah.
Anything else, Manuel, you want to add to that? I think you're the one that did all that.
No, I just mentioned that also Teku is supported.
And then just where is Dirk in the manual? Are we working on that, or is it?
Yes, I'm currently working on Dirk. I hope it's going to be ready next week, I think.
We have some reference Rust code that can also interact with like Dirk distributed accounts in order to produce a signature. I can send that over if that's helpful.
Oh yes, it would be helpful. Thank you.
Awesome.
Cool. It looks like we're at time. Yeah, any final thoughts? I guess one question, Drew, do you have a sense of when the next call would be?
Q1. Yeah.
Okay.
So either late January or mid-February, probably.
Okay, cool. Well, if there's nothing else, we'll go ahead and wrap up.
Thank you all.
Sweet.
Thank you a lot.
Thanks,
Thanks,
everyone. Bye.
Thank you.